Good day to everyone joining us and welcome to today's X Talks webinar. Today's talk is entitled, How to Improve Ready-to-Eat Food Processing Plants Through Sanitary Design. My name is Nima and I'll be your X Talks host for today. Today's webinar is designed to be interactive and webinars work best when you're involved. This webinar will run for 60 minutes and with time for a question and answer session with our speakers. Please feel free to submit your questions and comments for our speakers throughout the presentation using the questions chat box, and we'll try to attend to your questions during the Q&A session. This chat box is located in the control panel on the right-hand side of your screen. If you require any assistance, please contact me at any time by sending a message using this chat panel. At this time, all participants are in listen-only mode. Please note that this event will be recorded and made available for future download. At this point, I'd like to thank Birko, who helped to develop the content for this presentation. For over 65 years, Birko has delivered custom food safety chemistry, equipment, and technology to food and beverage companies, including CHAD equipment for protein harvest companies. Nothing is more important to Birko than making sure that the food chain is safe, secure, and pathogen-free. Companies choose and stay with Birko for a level of customer support that is second to none. It's all part of the Birko advantage, integrated food safety solutions provided by highly trained and experienced professionals who bring it all together to be your partner in food safety. Now I'd like to introduce our speakers for today's event. Bob Ogren has more than 22 years of experience in the food safety and food equipment industry. As the vice president of Birko's equipment division, Bob and his team custom builds Birko and CHAD equipment to meet facilities' food safety requirements and regularly consults companies on how to achieve optimal food safety while reducing costs. Bob holds a bachelor's degree in English with an emphasis in economics from the University of Kansas. Dr. Ellis Owens leads Birko's team of technical experts involved in R&D, quality assurance, regulatory compliance, and customer education and support. Ellis is a sought-after speaker who's been published in peer-reviewed journals and industry publications, and is a co-inventor on a number of Birko's patent applications, including beef-side and chick-side blends of lactic and citric acids. Ellis earned his PhD from Cardiff University in Wales and conducted postdoctoral research at Michigan State University's Center for Microbial Ecology. And now, without further ado, I'd like to hand the mic over to our first speaker. Ellis, you may begin the presentation whenever you are ready.
Okay, good afternoon. Hello, everybody, and thank you for joining us for the webinar. Nima, I'd like to thank you for the introduction, and I'd like you to move on to the next slide, please. You can skip that one as well. Thank you. Great. So just to add to the comments that Nima made about Birko, we are a third generation 65-year-old family-owned company, and really our core competency, the only thing we do is to provide innovative food safety solutions by combining chemistry, equipment, and technology with an outstanding level of customer service. Next slide, please. Our R&D team, sales team, and technical experts have several hundred years of experience dealing with food safety challenges across the entire spectrum of the food processing industry. There really isn't a lot out there that we haven't seen or had to help our customers with. One of the biggest challenges we see, particularly in the RTE food processing space, and that's both for RTE proteins and for RTE or ready-to-eat produce, is challenges related to the sanitary design of the facilities or the sanitary design of the processing equipment. Things just aren't designed for easy cleaning, easy sanitation, or they contain harborage areas which can become sources of contamination during food processing. Obviously, these can be things which can lead to outbreaks of foodborne illness, and a foodborne illness can have a major impact on your brand or a severe impact on your bottom line. So our objective today is to share some of our knowledge, some of our experience, and arm you with a toolbox of ideas that you can take back and look at your own facility with and see whether some areas for improvement, some changes you can make to improve both the sanitary design of your equipment and your facility. Next slide, please. So when we think about world-class food safety through a Birko lens, there are a number of factors which go into making a world-class food safety program. Things like employee safety, training, and having a documented plan. One of the other components that is really foundational to having a world-class food safety system is having a sanitary processing facility and sanitary design. Next slide.
Okay, so I'll take it from here. Ellis, what is sanitary design? In the broadest sense, it's a food processing facility that is functional and efficient in design and allows for food to be processed safely in an intended manner. It's also cleanable to an acceptable standard in a reasonable time period. And one in which we see in sanitation where that window is shrinking seemingly by the day. We have less and less time to perform sanitation. They want more uptime. Also maintaining sanitary space for the duration of processing operations. It's cost effective to operate, all which leads to sanitation process, which provides consistent and repeatable results. Next slide, please. Okay, the why of food safety, sanitation, and sanitary design. So that prevents foodborne illnesses. Regulations tell us we have to, FSMA, FDA, and USDA, risk management, product liability, personal liability, brand reputation, and I would add probably more appropriately brand protection. And then also one other bullet point I would add is creates operational efficiency gains, which we'll discuss a little bit more detail later. Effective sanitary design and sanitation is a cornerstone of product quality, as producers and manufacturers need to take ownership of that process. Next slide, please.
So where do we come up with some of the principles for sanitary design? What guidance is available out there? Really kind of one of the places where the concept of sanitary design began and where some of the first concepts around sanitary design came from the North American Meat Institute. In 2014, they actually published a sanitary design checklist, which is, I believe, is available for download as one of the handouts. And if we can go on to the next slide. This then begins to talk about some of the 10 principles of sanitary design, 10 key concepts that need to be considered. So things like cleanable to a microbiological level, made of compatible materials, accessible, eliminates niches where product or liquid, which can become food for microbes, can accumulate, making sure that all the hollow areas are hermetically sealed, no hard to clean or hidden areas, stay sanitary during operation, maintenance enclosures, control panels are hygienically designed. There's hygienic compatibility with other plant systems, and finally, of course, you have to have validated cleaning and sanitation protocols. If we can move on to the next slide, we can start to actually dig into some of these. So when we say cleanable to a microbiological level, what do we mean? So really, what our goal is, cleanable to a level where we can eliminate pathogens, things like E. coli, particularly E. coli 15787, and the other S-Tech E. colis, eliminate salmonella, and particularly in the ready-to-eat environment, eliminating listeria. Other parts Other concepts around cleanability are eliminating any soil residues from the equipment. Soil can become a food for microbes. Removing the microbes so they don't cross-contaminate the product, and then preventing or eliminating the formation of biofilms. Next slide. A new concept that's kind of coming to fore in food safety microbiology is the concept of transient versus resident microorganisms, or transient versus resident bacteria. A transient organism is one that typically comes into the plant on the product, on your raw materials, and then leaves with the product. It may contaminate the processing space for that day, but usually it's not going to persist in the plant environment for a long period of time. Then we have the resident or the pet strains or the house strains. Frequently, these are going to be listeria. This is where an organism can perhaps move into the plant, take up residence. And there's been some interesting work done by Martin Wiedemann out of Cornell, amongst others, where they've used whole genome sequencing to show that the same strains of listeria are being found in a plant in different areas of that plant over a period of 10 or more years. This is an indicator that you've got a resident population of that microbe somewhere in your plant that kind of comes and goes. It hides. It comes out. It's hiding in areas where it may not be removed by your regular sanitation program. It may contaminate the product as it moves through the process, and it may be in the form of a biofilm. Next slide. Just to touch base briefly what we mean by a biofilm. Typically, this is where free-living or planktonic bacteria are absorbed onto a surface, and they excrete or they put out an extracellular polysaccharide glue, which sticks them to the surface and makes them resistant to removal by regular cleaning and sanitation chemicals. They can grow in that form a larger colony, and then as food moves or as product moves over that surface, it can scrape off some of the bacteria, and it can become a source of contamination. This is a common form for microbes living in cooler, damp environments like drains, floors, nooks and crannies, crevices. Next slide, please. Biofilm can be a major concern for food processors, especially for RTE manufacturers. Typically resistant to conventional cleaning and sanitation processes, and it's a frequent culprit where persistent microbial contamination is a problem. Extremely common in drains, and often specialty products are required for their removal. Next slide.
So we need to ensure that the equipment that we're manufacturing for our plants is made of compatible materials. This obviously includes stainless steel, and the best grades of which are 303, 304, and 316. 303 is ideal for machining. We use that for parts, spare parts, small pieces. 304 is ideal for welding. Much of our equipment, cabinets, frames come from 304 stainless. And 316 has superior chemical and corrosion resistance, but less machinability and weldability, and it's more expensive. On the plastics, Delrin, nylon, and UHMW are typically used, with UHMW probably being the best for chemical resistance. However, lately we've been using more of Tectron PPS, which has superior chemical resistance, but the trade-off is less machinability and a higher cost. In fact, Tectron is typically 2 to 3 times as expensive as UHMW. The benefit, though, is that it lasts 2 to 3 times longer than UHMW. Next slide, please. Accessibility. So accessible for inspection, maintenance, cleaning, and sanitation. Are all the parts of the equipment reachable from the floor level, platforms, catwalks, or ladders? Does it need to be dismantled? Are special tools or skills needed? If so, who handles this task? Is it maintenance or is it sanitation? Can disassembly be made easier? Quick clamps versus bolts. Are there options to retrofit existing equipment? Engage your whole team. And by that, what we're talking about is engaging the maintenance team, sanitation, and I would even suggest that you would go back to the manufacturer, because it's interesting to know that the equipment that you purchase for your plant is going to be there for 10, 20, 30 years. And oftentimes there's multiple iterations that come through in design improvements. And by going back to the manufacturer, sometimes you can incorporate upgrades. And then finally, are there hidden areas and or items that are out of sight? Next slide, please.
So this is just an example of some hidden areas. These were actually taken in a fruit packing facility where they actually happened to be tearing out their flumes. And the top two images there are just some examples of water recirculation lines for flumes. And as you can see, there's a wonderful, colorful buildup of wax and microbial growth and mold and all kinds of interesting stuff growing there. So this is a good example of a hidden area that really hadn't been cleaned thoroughly in many, many years. And then in the lower images on the left, we have the underside of an apple processing brush bed, where you can see kind of it's some hard to clean areas and some buildup of debris alongside the brushes. And then in the lower right, we have another example of the flume. We've just got a little kind of pocket that's not being cleaned, or it's hard to clean. We've got leaves and other debris accumulating. Next slide.
So we also want to try and eliminate all niches. And a niche is anywhere that's difficult to clean, that typically traps soil and bacteria. Also, it's anywhere there's a hidden area or shadow that's a potential niche, as well as design out of new equipment. And by that, what we mean is that we would like for the producers to engage with the manufacturer. Again, as I mentioned earlier, many times our iterations have improved upon previous design, and you'll never know unless you ask. And so it's good to reach out to the supplier. Also, retrofit old equipment to eliminate the niche. And the niches can develop over time as equipment ages and wears, so we need to stay vigilant. Next slide, please. And so here we have some illustrations of a hygiene risk on the far left with hidden areas. And then we have an acceptable just to the right of that, where we lack the hidden areas. It's more open, and we're able to have visibility. And then Ellis, do you want to discuss the pressure gauges?
Yeah, I just want to comment briefly on the pressure gauges, because that's frequently an overlooked area, particularly for liquid processing in like a juice plant, something like that. Regular pressure gauges with a threaded fitting on the bottom actually have a hollow tube and coil going up inside the gauge, which is basically impossible to clean. So if you are needing to measure the pressure of the food product you're processing during processing, you should always make sure that you use a proper sanitary pressure gauge, like the ones on the lower right that have the stainless steel membrane that separates the coil from the actual food product. Next slide.
So here we have unsanitary interlocking belts displayed, zero open, flat, closed hinge, interlocking plastic modular conveyor belt, which you see in just about every single plant. Very difficult to clean, obviously. Next slide, please. And why is it unsanitary? Well, the reason is there's thousands of closed hinge points that make it next to impossible to clean. It also leads to potential soil micro harborage. And then basically tens of thousands of failed ATP results have proven this belt to be hard to clean. And if you've obviously seen during sanitation, probably one of the most tedious tasks there is in the plant is cleaning these belts. They stand in the end of the belt, and they're simply moving a hose back and forth as the belt passes by, never really knowing when you've had how many rotations and when it's truly clean. Next slide, please. Other types of unsanitary belting are fiber-backed rubber belting. Also, it's an excellent source of soil microharborage. And also the use of metal lacing is another harborage issue in the photo to the right. Next slide, please. So better interlocking style. If interlocking conveyor is something that you have to have, then a 50% plus open style is recommended for proper access to pins and hinges for cleaning. However, be aware, the more open, potentially the less durable, and also the more susceptible to damage during production. Next slide, please. And here we've got what I would consider to be more hygienic conveyor design. The stainless steel vibratory conveyors used predominantly in the produce industry, and then also stainless steel wire mesh conveyors, which you can see is more than 50% open. Both of these have no hidden areas, no harborage points. Next slide, please. And then we have actually an improving design. Here's a solid thermoplastic belting, which has no hinges, pins, it's seamless. So there's no niches for soil microaccumulation. It can be cleaned in place. Obviously easier to clean than the other belts and uses less water. Next slide, please. So the conveyor spray bars, this is something that we've seen more and more of in the industry. It's becoming adapted. Because the task of cleaning these belts is so tedious, and mind-numbing, actually, the idea of automating has kind of taken hold. What that does is reduce the amount of water you use. It's easier than removing the belts. It also can be used to apply a foam and a sanitizer. And so you rinse, foam, dwell, rinse, and then sanitize. And it also allows for a consistent, repeatable, automated process. Next slide, please. So proper conveyor design, if you take a look at the photo on the right, the side panels are not open, so there's very little access. The tension belt is a fibrous inner construction, and it cannot be lifted for access. And then take a look at the belt on the right, I'm sorry, on the left. It is angle iron framework. It's open access for cleaning. The belt is solid thermoplastic. And if you look closely, you can see that the side railings are actually bolted on surface and spaced. So you have easy cleaning around that point as well as around the belt itself. So if you look at as we discussed earlier, if you think about operational efficiency gains, and take a look at these two designs over time, clearly the belt on the right is going to take much more time to clean, if it can ever get cleaned effectively, versus the belt on the left. Next slide, please. Okay, conveyor with hollow rollers. Hollow rollers are known harborage points, and I wouldn't say should, they must be eliminated. The rollers also must be of solid design or utilize solid plastic runners as seen below. Next slide, please. And sandwich and surface joints. Any sandwich surfaces should be disassembled for cleaning, like fastback vibrator hopper chute, shown on the left and right. And next slide, please. And sandwich surfaces. Conveyor scrapers should be removed for COP cleaning or properly designed for easy removal access of cleaning. And then you see both the sandwich unsanitary and the one on the right, which is one piece removable. Next slide, please. We'll cover lap surfaces. Any lap surface should be disassembled for cleaning, like a fastback extension to the sheet of scales and to the PacMac bagger shown here. Next slide, please. And so unsanitary welds. On the photo on the right, you see that the attack welding or stitch welding was done on the back side of it. That's an indication that the welding was done at too high of a temperature. It's actually deformed the surface of the equipment, and so that creates harborage points. Rough unsanitary welds or cracked or pitted welds. If you look at the photo down below on the right, clearly that's something that needed to be ground down and re-welded because that is an excellent harborage point for bacterial growth. Next slide, please. Unsanitary fabrication. Expanded metal is uncleanable, and if you look at the photo, you see the bolted on lap surface. It's also considered to be an unsanitary add-on, and there's bad welds as included, so it covers all the bad things. Next slide, please. This is something, unfortunately, we see quite a bit in plants. The hollow framework, it gets, obviously it could at one point in time be sealed, but it does crack or gets penetrated. It's open-ended, and you see that time and time again where you have water accumulating in there with different proteins, and it obviously creates a very unsanitary situation, which could lead to Category 3 black water. It's considered grossly unsanitary. Next slide, please. So more on hollow framework. We like to use channel and angle and solid stainless steel rod versus tubing and pipe. But you can see down below on the left, that's exactly, we have a hollow leg framework. And it is very difficult to get totally sealed. If it is, it will crack with age. So you see on the right above a better version, but the best is obviously with channel or angle. Next slide, please. So hygienic design of enclosures, pumps, and motors. Equipment enclosures should have a NEMA rating. We actually recommend NEMA 4X. That's all we'll use, and that rating indicates that it will withstand a low pressure washdown. And then as far as pumps and motors, they fall under IP ratings. We typically, I would say almost always, use IP69, which indicates a component is fully submersible. And it's important to check because there are times where you'll have components that are made up of IP69 rated material and also IP67 rated material. And obviously, if this is the case, you got to default to the lower rating. We've had photo eyes, and we didn't actually know it at the time, but the photo eye had a pin connection that was IP rated 67. This was put in a situation where there was some washdown situation for cleaning, and the photo eyes failed. And only then did we realize that one component was actually 67 and not 69. Next slide, please. So hygienic design of enclosures. We've added spacers between the components for less surface-to-surface contact, allowing for effective cleaning. We've also just recently started utilizing sloped surfaces when possible to promote drainage. And this also has a carryover effect that it prevents plant personnel from using it as a shelf to place things on. And all electrical penetration should be through the bottom of the enclosures. Next slide, please. Now, hygienic compatibility. Have the systems been designed with cleaning in mind? And are all the materials cleanable using similar chemistry? Also, I want to add to this, one thing that we mentioned earlier and I want to bring up again is engaging the manufacturer. A lot of these points that we're bringing up, it's interesting. We learn by being out in the field and also working with other manufacturers. Also, I would recommend that there's a factory acceptance test, that you make sure that you're involved in that process of design and build, and make sure that the manufacturer you're working with is engaged. And keep in mind that equipment is going to typically last for 20 or 30 years. I mean, millions of pounds of food pass through it, and it'll be cleaned thousands of times. Next slide, please. And I call this the we thought we knew what we were doing 20 years ago slide. I'm not trying to knock Ashita because I mean that for everybody. If you look at the Ashita scale head on the left versus the right, the left obviously has aluminum surface and it does not provide for a cleanable surface and it becomes a harborage point. We obviously recommend stainless steel that's compatible with wet environments, and cleaners required for optimum food safety. Next slide, please.
So Bob's talked a lot about the actual design of the equipment. I'd like to take a few minutes now to talk more about some of the things about facility design and some of the hot spots we see in just the overall design of the facility that can also contribute to poor sanitary design. So some kind of hot areas that we see are as poorly designed catwalks and access platforms, the design and location of drains, curbing, location of the equipment in the facility, and flooring. Next slide, please. So it's important to have good catwalks and access platforms for the people who are working on and around the production line and the processing equipment. Part of that is it gives them a good way to access. It gives them a good way to access the equipment for both work and for cleaning. However, there's some things we need to think about when it comes to how we design, how we install those catwalks. We've seen a lot of the ChemGrate, which is that kind of green plastic fiberglass type of material. Looks great when it's first installed, but over time it begins to break down. It begins to break down with exposure to cleaning chemistry, sanitation chemistry, abrasion, mechanical activity. And as it begins to fall apart, it develops all kinds of harborage areas. Even though it's removable, people tend not to remove it for effective cleaning. So we like to see that either not installed to begin with, or would recommend you look at other options such as bead blasted or pebbled stainless, diamond plate, other more durable materials for making stairs and or catwalks and access platforms. Next slide. Drains, one of my favorites and a key area for any ready to eat facility. On the lower left, we've got an old trench drain with I can't tell if that's a fiberglass ChemGrate cover over it, or if that's actually a cast steel cover over it. But you can also see there that you've got some exposed aggregate around there. It's an open trench drain, which means it could be shedding microorganisms into the environment as liquid flows through it. It's also really prone to being hit with a hose during sanitation and forming aerosols of debris up out of the drain onto your equipment. Up in the top right, we've got a multi-component square basket, again made from black iron, and then the epoxy floor covering around that is cracked. Again, you've got standing water in the basket, makes it difficult to clean. It's a black iron, it's rusted. Again, multiple harborage areas, extremely hard to clean. And then my favorite in the middle. Looks like it's a nice stainless steel drain. However, it's welded shut, so there's no way you can get in there to clean it. I know some people argue that, well, it stops debris getting down into the drains, but really, if you've got your drains welded shut, you can't clean them, and that's asking for trouble. Next slide. So here are some examples of a newer, much more sanitary design stainless steel floor drain. It's round, stainless steel, single piece construction, doesn't have any lapped seams, any lapped surfaces, no seams, and it's installed with the floors sloped properly towards other drains. And then it's got a catch, and then it has a catch basket which will trap solid debris and is easily removed for cleaning. Next slide. So, in addition to having good drains, you need to look at, are the drains functional and are they moving water out of the facility? If you've got pooled or standing water in your facility, that's a good indicator that you don't have adequate drainage, you don't have clean drains, or that you have floors which are not sloped towards other drains. If you've got standing water like that, you've got all kinds of microorganisms possibly swimming up out of those drains and onto the floor of your facility. Other thing to think about with the drains is if you look at the lower right, you've got a condensate tray underneath an overhead cooling unit. Obviously, that has a drain which is plumbed to allow that condensate water to drain away. That should be plumbed to a drain outside the wall, away from the processing area. Ideally, you should also have some type of quad block or time release sanitizer in that pan to inhibit the growth of microbes, but you certainly don't want the liquid from that pan draining down onto your production floor. That's been a documented source of foodborne listeria outbreaks in the past. Next slide. Unsanitary floors. So if you see problems with the floors, that can be a key harborage area. So the large picture on the left-hand side, that floor is so old that the top layer of the concrete has completely eroded away, leaving you with a nice layer of exposed aggregate and table legs kind of hanging in midair. That floor is basically unsanitary. It's uncleanable. Without replacement or coating or sealing in some way, that floor will never provide you with a sanitary environment. Epoxy type coatings are a great option, but they need to be maintained. In the top, up in the top right, you can see one where the epoxy is beginning to break away, and you have an exposed patch that's not that's allowing some harborage areas. And then in the lower left, you can see where the epoxy has begun to peel up from the bricks, and you've got moisture penetration underneath the epoxy. That's a great harborage area which can be almost impossible to clean. If you have a situation like that in your facility where you've got cracked or broken epoxy which is lifting up off the floor, or it could be a stainless steel floor plate, something like that, stand or tread heavily on the edge of the epoxy and look to see if you have water squirting out or liquid squirting out from underneath that epoxy. If you've got liquid squirting out from underneath that epoxy, that's a really good indicator that you have a harborage area there. And this may be something to think about. If you have that type of situation, when you're out there doing your environmental sampling for listeria or for other microorganisms, when you sample that kind of area, stand on the epoxy so any liquid is coming out, and then swab that liquid to look for microbes. We've seen multiple instances of listeria forming in exactly this type of environment in a ready-to-eat plant. Next slide, please. In addition to the floors, the curbs, that kind of first initial foot or so of the wall coming up from the floor. Here again, we've got exposed concrete that really needs to be sealed in the same way as the floor. So, and then need to make sure that the junction between the curb and the floor, and then the curb and the wall above the curb are properly sealed. And there we have a condensate drain coming directly down to the floor. Something else to look at in that type of environment is if you have carts which you're moving product around on, and you've got standing water on the floor, look for tide lines on your curb to see just how far up the wall that standing water is being splashed as you move those carts around. I was in it's a ready-to-eat meat facility where they had wheeled smokehouse carts, and as you began to look in their coolers and on the cooked side of the plant, you could actually see a tide line on the wall where liquid from the floor was splashing up from the wheels, and that tide line was higher than the lower level on the smokehouse rack. So it was quite conceivable that liquid from the floor was coming up into contact with the cooked food items on the smokehouse racks. Next slide, please. How the equipment is located in the facility is also important. It needs to be positioned so there's access all around the equipment for cleaning and for sanitation. It needs to be up off the floor so liquid isn't going to splash to it. Here are a couple examples. We've got portions of the equipment basically in contact with the floor. Extremely difficult to maintain that in a sanitary environment during the processing day. Next slide, please. So other things to think about. So we've talked about having this kind of having this sanitary designed equipment and then having this sanitary designed facility. So some parts of this then is how do we maintain that sanitary space during the processing day? Obviously, one way to try to do that is to isolate the work area and to keep it clean. Control people who have access to those areas. Provide entryway foamers where you're putting a quart-based foam down on the floor that people walk through or that forklifts drive through to clean and sanitize the tires or the soles of their shoes. Make sure they have, make sure you have a regular cleaning program for boots, truck tires, forklift wheels. If it's more of a dry area, you can look at using an antimicrobial floor powder to help inhibit the bacterial growth. As I've mentioned, using quart blocks or similar time release sanitizers in the overhead cooling condensate trays, and then try if you can to divide the plant up into clean areas, dirty areas, control movement between those areas, so you don't have this, people from the dirty or say the raw side of a ready-to-eat plant going over into the cooked side without changing PPE, changing their clothing, changing their boots, things like that. Try to segregate spaces like that. Next slide, please. Something else to think about when it comes to sanitary design is also protecting the stainless steel surfaces on the equipment. If you're not doing it, think about doing a passivation step. This is basically a chemical pre-treatment that can be done periodically to put an oxide or a silicate film onto the stainless steel surfaces that help to seal them, make them more resistant to the cleaning chemicals, and can perhaps make them easier to clean. Typically, it's an acid-based process. We have some unique ways of doing that, but it's something that should be built in as part of your preventive maintenance schedule to help maintain a sanitary processing environment. Next slide, please. So to kind of wrap things up and start to move into the question phase, in today's regulatory landscape, and with the changing market in the food industry, with this increased focus on ready-to-eat and convenience foods, there needs to be a much greater emphasis on food safety at the processor level. A lot of things are going to go straight from the food processing plant straight to the consumer's plate or the consumer's mouth. So really, it's putting a lot of the responsibility on the processor to make sure that the food is safe. Less food is being cooked after it leaves the processing facility. The other thing that we need to think about this is that the ways people purchase and consume foods is constantly changing. Many items out there which typically aren't or haven't been eaten raw in the past could easily become tomorrow's must-have raw food, ready to eat a delicacy. An example of that is kale. 5 years ago, kale was pretty much always eaten cooked. Now everyone's eating kale smoothies. Things like that. Things we need to think about. We need to think about how consumers are using our food products and adjust our food safety practices accordingly to accommodate that. So as we've talked about today, sanitary design of equipment and facilities is an important part of a multifaceted approach to food safety that is essential for all processors. And if you're not thinking about it now, I would really encourage you to start doing it because it's only going to get harder. Next slide, please. So how do we get there? What are some first steps in doing this? Really good sanitary design is going to be a collaborative effort between equipment manufacturers, collaboration between different food processors. Food safety really shouldn't be seen as a competitive advantage. Everybody should be trying to strive to achieve the maximum standards of food safety. If you've got something in your plant that's working well for food safety, try to find a way to share that with your colleagues in other parts of the food industry. It's only by sharing that, by developing that shared collective knowledge base that we can raise the overall standards of food safety. Engage your engage your sanitation chemical companies. They've seen a lot. They know a lot about chemical compatibility. Prior to making changes to your facility, talk to them about what we should do for enhanced sanitation during construction, or how we clean something new that's coming in. If you're bringing in a new piece of equipment, engage the chemical company, engage your sanitation team or your third-party sanitation provider, so you have a sanitation plan and sanitation products in place prior to that piece of equipment being installed. Demand sanitary design compliance when purchasing equipment or building new facilities. Review and upgrade your existing facilities and equipment where possible. And obviously, a lot of what we're talking about today has a cost to it. It's going to cost to upgrade your facilities. It's going to cost to upgrade your equipment. Demanding a high level of sanitary design in your new equipment is going to cost more. Some things you can probably but you need to recognize that. And as you're talking to executive management, explaining why we need to go with this higher standard of sanitary, higher standard of sanitary design, it's important to remember that regulation is becoming stricter. FDA is now collaborating with Department of Justice during foodborne outbreaks, and will seek criminal charges against people if there's an indication that there was perhaps negligence, or if there was knowledge that there was a lack of food safety preparedness in a facility. So we're now starting to move beyond the cost of a recall, the loss of a brand reputation, to more serious personal and criminal liability concepts. So these are things that we'd like to avoid. Next slide, please. So with that, I would like to thank you for your attendance, for your participation today. I know we haven't given you all of the answers, but I hope we've given you some information, some tools, some new ways of looking at things that you can take home to into your existing facilities, and look to see what other, what are my areas of concern? Could this be a problem area? What can I do? What can I do moving forward to make some changes to improve sanitary design in my facility, of my equipment, and raise my standards of food safety? Thank you very much.
Well, thank you very much for that insightful presentation. Now I would like to invite our audience to continue sending in their questions or comments right now using the questions window for the Q&A portion of this webinar. I've already received a few questions, so let's start with those. So our first question here is, you've covered a lot of information. What is a good first step, and where do we start?
I think for me, the first place that I would really start is look for those basically go out onto your production floor and look for those hollow table legs, look for those hollow support structures, look for those holes in the wall, look for those little things that could be niches and things like that. A really simple one is an example I saw in a fruit processing facility. They had a number of metal pipes coming up vertically out of the ground, which were basically used as bollards to prevent forklifts running into equipment. The tops of these were all open, and when you look down into them, you saw that the production team was using them as really convenient trash cans. I went back to that facility a year later, and all of those had been sealed up. So, you can start with simple things by just, okay, how can I divide my plant into clean zones, dirty zones? How can I seal up some of the hollow areas? That's probably where I would start.
I would add to that. I think, Alice, that's a good point. One of the things that I would consider is that there are oftentimes what I would call dark or hard to hit areas of the plant during sanitation. And all the plants have various degrees of new versus old equipment. But in particular, looking at those old equipment, see if there's a way to potentially automate the cleaning process. And what that will do is create a repeatable event that can be monitored. So I think Alice's a great point, but I also think I would try and automate certain processes that may get overlooked.
All right, thank you so much for those answers. Our next question here is, what advice do you have for convincing our upper management to invest more in sanitation and in new equipment that follows some of the design principles that you talked about?
So one of the things I would suggest, and we touched on it briefly in one of the slides, is that sometimes when you're looking at a piece of equipment that is the latest in sanitary design, you're obviously there's going to be a price for that. It's going to cost potentially more, and that's what I would say leaves some people gun shy from going into that. They opt for other equipment. What I would potentially do is discuss the operational efficiency gains of purchasing a piece of equipment that has incorporated sanitary design as part of the design of that unit, being that it's going to take far less time night after night for you to clean that and clean it more effectively than another piece of equipment that was not designed properly. So I think that, you know, they look at the initial cost, and of course, you know, they want to know what the ROI is. Well, there's a real ROI when you start considering the time it will take for you to clean that night after night. I think it really adds up.
Yes, and not just the ROI on the time taken for cleaning and things like that, but you just have to look at, you know, you look at some of the recent foodborne illness outbreaks or things which have come from that. You look at the outbreak of listeria that was associated with cantaloupe coming out of Jensen Farms in Colorado, or I believe it was the Peanut Corporation of America. Their senior management was aware that there were foods, or well, in the Peanut Corporation, senior management was aware that there were food safety deficiencies, and they ignored it. They were prosecuted, and I believe they're currently in jail. Jensen Farms, there was also a criminal prosecution just because of negligence, not really knowing what needed to be done in terms of food safety. So there's a real, you know, cost involved. Is if you don't spend the money up front to do things correctly, there is a risk that at some point you will end up facing the cost of a recall, facing to pay out consumer compensation, possibly even more extreme sanctions.
All right, thank you so much for those answers. Our next question here is, what's the biggest barrier you've seen in implementing sanitary design in a facility?
I think really for me, what the, you know, it's probably the shock value of the initial cost in doing things correctly, or there's a mentality in some parts of the food industry where, you know, anything we do that takes away from production time is costing us money. It's really kind of thinking about that, coupled with a lack of knowledge. People just don't know what's needed for good sanitary designs. Really, it's kind of it's the cost, it's the concern that it's taking time away from production, and then just people don't know or are unsure of what to do.
I'd like to add to that, Alice. I'm sometimes shocked by the when we have a producer come to us and they want to purchase equipment. There's a various degrees of engagement, and I think that typically it's the plant owner or manager that doesn't really know what's out there or doesn't care to know, just knows he needs a piece of equipment. I think that today, as you mentioned, I mean, it's more critical than ever to know exactly what you're getting and to be engaged with the manufacturer as that equipment enters into the plant.
All right, thank you so much for those answers. We have enough time to squeeze in one more question. And that question here is, it's difficult for us to find and retain good employees to handle our sanitation and cleaning. How can we ensure food safety despite having less or untrained employees?
The first answer that comes to my mind is you automate many of the processes where you find those issues. It's usually the most mind-numbing, rote jobs that you'll find that you have the most difficult time getting people to stay in those positions for obvious reasons. So if you can automate that process, you automatically create a repeatable event that utilizes less water, less chemical, altogether less resources, and yet does a consistent job. So when you have those issues, and I think that it's only going to get worse, there are opportunities to automate, and it will create a repeatable, monitored event.
Absolutely. I would say, automation is definitely an approach that that can be implemented moving forward as you retrofit, as you upgrade, as you build new facilities. Another option is really kind of, show the sanitation team that they are valued, make them feel important. They're not just the third shift people coming in to clean up. Make them realize that they are a key component of your food safety team. Figure out ways to incentivize them to do a good job. If you're doing ATP testing or environmental swabs, have something where have standards where if they consistently, you have no ATP failures for a week, you buy them lunch or something like that. Make them feel a valued and important part of the food safety team.
Well, thank you very much for those answers. We've reached the end of the question and answer portion of this webinar. Thank you everyone for participating in today's conference. You will be receiving a follow-up email from X-Talks with access to the recorded archive for this event. A survey window will be popping up on your screen, and your participation is appreciated as it will help us to improve our webinars. Now, please join us in thanking our speakers, Bob Ogren and Ellis Owens, by sending a quick message through the chat panel. We hope you found this conference informative. Have a great day, everyone.